everybody. Thanks for joining this session. I will tell you more about OpenTelemetry and how I solved problems with it on production and how you can solve production problems too. About 9 years ago, we were sitting in the office. Before COVID, we were all sitting in the office most of the time. But someone came at us and they knocked on the door, opened the door and asked, guys, do you have some problems with your services? I don't know. We can have a look. At that moment we were running a lot of open data services for the government. It was used by the company internally, but also a lot of users nationwide. So if they faced a problem and knocked on our door, then probably also a lot of others were facing problems. And we didn't know. And to me it felt pretty embarrassing that they have to tell us that we had problems. So there also, my journey also on monitoring and observability started. What's in the end, it's about your code, which is running on production. And there are all kind of feedback loops you can have about what you can do to get your code to production, etc. But in the end, it's about your code going to production. And it's also about what do you learn from it, and that you can get the information back from your production environment, and how can you improve your code. Because that's important, because if you don't get that feedback cycle properly, you don't know what's going on in production, and you don't know what issues are faced by the customer, and you can't fix it. So you need that feedback loop. About me, I'm Cees Bos. I'm a software developer, observability engineer, site reliability engineer. I've done all these things. I'm also a Grafana champion, but I'm working always to see what's going on production. How can we what can we learn from it? How can we solve it? What can we fix it? How can we fix it? And I like to visualize that, because if you make that visual, you better understand what's going on, and also you better understand if the fixes you do are working properly. If you have any questions, you can scan the QR code and drop a question at Slido. I'll try to answer them at the end. And if there are no time, I will try to answer them even after the session. And also, the information about this presentation is also available on my website. Go to ceesbos.nl, JCon 2025. The slide is available, but also code examples and how you can run it also locally yourself as well. And here's also the hashtag which you can use for the questions on Slido. A few years back, I was working on another project. There was one service running, one machine, a lot of small containers were running. And they asked me, okay, Cees, can you help? Because we have a lot of problems, it's unstable, and we don't know what's actually going on. Can you help us out? But so these containers were created by an external vendor. We were able to have a look at the code because of the agreements made, but the external vendor made the changes to the code. And what we saw on production was that sometimes these containers were growing in memory. And I thought, okay, but these services just get a request, do some processing, release it. Could it be that there is a memory issue? Memory leak, keeping things in memory or whatever. But we need more insights in this. Because if you have just containers growing and it's all running on one machine, in the end you reach your memory limit. The out of memory killer from Linux is coming on, and in the end it kills a container and it's gone. And they didn't even configure auto restart, so gone. So that will also cause the instability and lose of functionality. But in the end it's about how can you observe what is going on? How do you know what's going on in the container or your application, or if it's a microservice or a monolith, you still want to know what's going on. And it can be a black box. Or if you use OpenTelemetry, it helps to get more insights. It can turn into a white box. And then you see that actually a lot is going on in it. And that can help you to understand what is going on and how you can fix it. Or if it's all running fine, because that's fine as well. OpenTelemetry. What is OpenTelemetry? OpenTelemetry, it has a lot of things. First of all, it's vendor agnostic. It's open source. It's part of CNCF. You have Kubernetes, which is the most known part of CNCF, the Cloud Native Foundation. That is Kubernetes is the largest project, but the second one is OpenTelemetry. And a lot of vendors in the observability space are contributing to this and working together on OpenTelemetry for the data ingestion side. It has a lot of APIs, SDKs, or libraries that you can use in your language, your programming language, and especially also Java. That's why we're here. And you can use that to get more insights in what's going on in your code. It also has the OpenTelemetry line protocol. That is the protocol which is used to send the data from your application to either a collector or the backend services where the data is stored. That is all standardized. And also there's, and that's a very important part, there's conventions, so the naming conventions. How do you name, for example, the metrics, and what kind of attributes do you use, and how do you call that? And that is all standardized, and that makes it also possible that you can do a lot of analysis, not only just on a single application, but also on a whole bunch of applications, even if they are in different programming languages. And we will come to that later. OpenTelemetry.io has very good documentation as well on how to use it and how to go forward with it. And this is a part of OpenTelemetry. And what you can see here is you have the auto instrumentation or the API or SDKs, so all the libraries which you can use to instrument your application. But it's not only limited to applications, because also Kubernetes, for example, gives a lot of observability data with OpenTelemetry. But also layer 7 proxies, so the load balancers, for example, also give a lot of information about the messages being sent, and also if even the requests do not reach your application, the load balancer probably gives already metrics as well, so then you can probably see why is the load balancer not able to send data to my application. In the end, all data is sent with the OpenTelemetry line protocol to whatever service you can have, but also an OpenTelemetry collector. There you can bring all the data together. You can enrich the data. You can also relabel a number of things. You can add information about the systems it's running on, for example. And in the end, you can send the data to observability backends. So time series databases like Prometheus or Mimir or any other type of storage where you can store the metric data, but also your traces or your logs, all in the profiles. You can all store that in all kind of storages. And this part is not part of OpenTelemetry. So all the vendors support OpenTelemetry. They say, okay, but if you have OpenTelemetry data, send it to us. But this is not part of the OpenTelemetry project itself. And what you also see is that a lot of databases, for example, also provide OpenTelemetry data themselves. So it's not only about requests done to the database, but also the database itself are more and more supporting this. I use locally a set of a number of tools provided by Grafana. I call it the Open Observability Toolkit, because that's one of the things I use locally in a number of cases. A few years back, someone asked me, what kind of tools do you use? And at that moment, I just sent a zip with some configuration files and Docker containers. So based with that, some Docker containers could be started. But then I thought, let's put it in a Git repo so more people can use it. But what you can see here as well, here you have the OpenTelemetry collector, where data is coming in. It's sent to the storages, and in the end, with Grafana, you can visualize it. And that helps to get more information out of it and to see what's going on. And also in this repo as well, I added some dashboards as well already, which can help you, and also which I will show in the demo. Back to the problems. So one of the problems was the memory issue we had. So I thought, what can we do? The external vendor made a change to the code. I asked, can we use Spring Actuator, for example? No, they didn't want to, for reasons. Then I thought, we can use OpenTelemetry. OpenTelemetry agent, you can use that to get even information out of the application if you can't change the code. Because OpenTelemetry has the support, what they nowadays call zero code, and that helps to get more information out of your application, and you can add it with the agent technology of the JVM. So the agent part is loaded first, and then your application is loaded, and that can hook into all kind of ways in the JVM. To start that, you have to change the Java path. So you have to say Java -dash Java agent and then the jar. So that is a bit of a problem if you just want to hook it into a container. But there is also another option. You can use the Java tools option environment variable, where you can specify, please use this agent, jar. And then you can leave the Java start path untouched. So with that, you can add this jar by putting it in a volume or use a host volume and connect it to your container. At the start with your container, add an additional environment variable, and then you can get information out of a container without modifying the image. Also on Kubernetes, you have ways to do this. You can do a number of things yourself with a config map and, for example, volume. And adding environment variables, but you can also use the OpenTelemetry operator, which is also using the auto-instrumentation part, and that's taking care of putting in the jar in your container, adding environment variables, etc. Two problems I will demo at first. One is the memory usage problem I talked about earlier. And another one is also one of the parts of the instability was that a number of times a null pointer exception occurred. We mentioned to them that this needs to be fixed, but they thought, we can see the line of code where it fails, but it's dependent on the data is being sent to it. So what data is sent to for this request? That's a good question. So and that's what I will show in this demo as well. In the setup there's a K6 test script putting load on the two services. The two services share the same code base, but are started twice in this case. And it's all sending telemetry data to the collector. So in the end, we can visualize it with Grafana. So I'll switch to the code. This is just a simple Spring Boot application. And here you see the endpoint, random behavior, so random, and an ID is put into it. You see here a log line, just the standard logging for Spring. Handle the exception if there is an exception. If it can't be handled, log an error, throw an exception. And what you can see here, nothing about OpenTelemetry. Also, if we check the POM file, except for the description where I put in OpenTelemetry, there is no OpenTelemetry in dependencies or whatever. The Docker file, it's just creating a Docker file, taking Java, putting the jar in, running it as non-root. And also here you see just the standard Java startup. The Docker compose file I use here, and what you can see here is, for example, the beta service. Here you see it's using the Docker file, tell to OpenTelemetry, this one is called beta, tell to Spring, this is called beta, and also, but this we'll see later, beta can send messages to alpha as well. And what you can see here is some more properties. Here you have the more environment variables, and here we have the volume mount. Just mount in the jar from the host machine, put it into a volume, make this available to the container. And if we then check the properties, here we see the Java tools option jar. Tell a number of things to OpenTelemetry, use the OTLP protocol, push it to the HTTP endpoint for HTTP protobuf, some timeout settings, and also that's available standard as well. You can use the JMX integration as well, and you can get some information about Tomcat right away. I started this all, and now I'll switch to this one. I created a dashboard, and here you just before this presentation, I already started just a small run. And what you can see here is because OpenTelemetry knows this is about Spring, so it knows also Tomcat, so it can already derive some information about that. So it knows about the incoming HTTP request, and you can see here that these requests are coming in. And I will start a second scenario now with the errors. And in the meantime, I will tell more about the dashboard. So here you see the HTTP requests. What you also get right away is the information about the JVM. So we can see the number of threads, the normal threads, also the daemon threads. We can have more information about heap usage and the non-heap. We can see garbage collector activities. And also from Tomcat, we can see the number of Tomcat threads and also active sessions, etc. if you use session-based actions. And we can have more information about traces. So a trace is where you can see a request is coming in on your application and keeps track of it. And also action, maybe if you create internal spans or doing actions to another service, you can get more information about it. And I will show you more in a minute. And also logs are available right away. So here you see also that log messages are printed. And we can see now more, if we check the incoming request, now we see more load is coming in, and also we see now errors coming in. So the K6 script I started is now resulting in errors as well. But about the memory problem. So when I had this information, I was checking the graphs, and I was looking at okay, but how much memory are these containers using? And I actually didn't see any problems because the heap was just growing, and then garbage collection came in. It was reducing again. But if you keep this running for a while on some days, and it hardly has load, it just keeps growing, and garbage collector is not that active. And then I checked, okay, but what is actually the max heap size? Because what happens if you have a machine with a lot of memory and just start a Java process, it thinks, I can use all the memory, no problem. And then based on that, it will take a part of that as for the heap. But if you have 17 containers running on the same machine, they all think, we have a lot of memory, no problem. And then memory starts growing. The JVM doesn't know there is a memory pressure. Only on operating system level there is a problem. So this small application can just grow to 8 GB of memory and then just do garbage collection and release it again. And nowadays that it's more often that the garbage collection brings it back. Java 11, at that moment it was still more eager to grow the memory. So making a small change can do a lot of things. So what I did at that moment, I changed the Docker Compose file. If you just tell, don't use all the memory, but just use a portion of it, and now I'll switch to alpha because that is same software, same version, etc. And if you then check the max memory, it's not 8 gigabyte, but only 250 megabyte. And that makes a lot of difference. And it might be that the garbage collector have to do a bit more or become more active at some moments, but it's perfectly able to handle it. Unless you just require more, but then you can change your configuration. So actually the growing memory and then it got killed was not a Java problem, not an application problem, but it was a configuration problem. But with having more insights, you are able to fix it. And that's what. Now we can have a look at the errors. So in the logging, we can see here we have more errors, and I will show. I'll go to Explore because then we can see it a bit more. So what you can see here is, and I will take it to the last 15 minutes. You see here, this is the log volume, so you see a lot of log messages are coming in because of the load we put on the service. A lot of info messages, but also error messages. And with this, OpenTelemetry is not just providing the message, but is also providing a lot of information with it. Because this is just a message, it's also the error level, but it's also recording the stack trace. But it's also giving you a lot more information on which host is it running, or which Java version is used, patch version, all these type of things. It's available. In this case, it's also telling this is coming from alpha. Also, which OpenTelemetry version is used, and also because it knows in which context a request is being done, it keeps also track of the trace. So with this, you can say, okay, but let's have a look at the trace. So this is the same trace. If it's sometimes, so this is the same trace, same information again. So you have the resource attributes. Again, also on trace level, you can see which version is being used and which Java version is used, which OpenTelemetry version is used. You can see here, this is a server span, so that means it's receiving a request, so it's handling it as a server. You can also see status error, and you have some more information about the request itself. So you can see more, about the request itself, so you can see which client is invoking it, so you have more context on this. And you can also see here which route was used and also which path. Come on. So here you have the path, and you see already here number 2. But what you can here do as well, from the trace, you can say, okay, give me all related log lines for this request. And then we'll go back to the logging again. So here you can see for this request which came in, there are actually 3 log lines related to this single request. So you can see here the error being recorded, but also at the start. It also is logging the information at the start. And if in our case we asked, okay, but can we log the payload of the incoming request in the logging? And then with the error, you are able to correlate it and see, okay, but we had the error, and also what was the payload of the same request in the logging. And you can try to do that with timings and see what was happening, and maybe also a thread ID on which thread was it logged, and then try to do it. But the context of your trace is way better to get this data. So with the correlation between the traces and the loss, you're able to get more information about what's going on in your application. So I'll go back to my presentation. A third problem. We saw a number of requests coming in, and at some moments, I saw also that the duration of the request was way higher. But then I thought this was a service connecting to an external party, but then I thought the high response times might be because of the external service, but that's used by a lot of companies throughout the country. I highly doubt if it's a problem at their side. So let's see where if we can find more information about it. So I'll start the next run. Again, a test scenario. Beta is sending a request to alpha to simulate this same problem. In this case, now I am able to see the metric data from alpha. At that moment, we were not able to see the metric of the other service because it was an external service. But that can help to get more information. How does this look like? Here we have a request coming in on beta, and then HTTP request is being done to alpha. If the response is okay, just return the body, and otherwise log an error. Now we go back to the screen. We refresh, we take the last 15 minutes. So here, this is just to check on alpha. We see here now requests are coming in, and we see here response times are in the same order, the same as before. And we see on alpha no errors. So alpha looks fine. Now we can check beta. And what you see here, no errors, request rate is going up. And we can see here already request duration is going up. And especially if you also check the average and the P95, it's going up already to 10 seconds now. So what's going on? And that's where we can have a look at the traces, for example, to see what is going on. And now I'll zoom into this part, because also with that, also the traces are from that part. So here we have one of these large requests. And if we open this one, what you can see here is beta is getting the request. This is again a server span. And here is alpha getting the request. So you see in one trace alpha and beta both available. Alpha is handling the request, and the duration is only 40 milliseconds. So that's fine. You also see here, this is the client part. So as client, beta is sending this request, but the client part only takes 40 milliseconds as well. But here in between, you see in this part, you see between the moment beta retrieved the request and the sending out the request, there is a lot of time. So apparently beta is doing not quite well with this. Let's see if we can find more information about that. So we have here the threads, and what I saw in the threads as well, that the number of blocked threads went up. So somehow something is blocking at the beta side. So, and now I'm wondering if you are all awake to see, because this is where the request is coming in. Here is the request is sent out. Can someone find the problem? Sorry? No. Yeah, synchronized. Because of the synchronized block, it's sending only one request to alpha at a time, and the others have to wait. So then you get contention in your application, and it's giving problems. So with more insights, then you can make the feedback loop. So what's going on production? What can we see from the metrics, from the traces, from the logs, and then check your code again. Can you find the problems in your code? And then you have to fix things like this, and then also the response times are fine. So, a fourth problem. I had a Quarkus native application, a portal. I'm also a volunteer in a church. I created a portal where everyone can log in and see, okay, but to what SharePoint sites do I have access? As a convenient way, a start point for them. To do that, I use the MS Graph SDK API to connect to Microsoft. That has the OK HTTP client, but it was not that observable at the moment. So I hope it's a bit readable, but what you can see here is just the request was coming in. And at this moment, the request was coming in on the portal, and it took 4 seconds to give the response on, okay, but these are the sites you are able to access, and also giving all the URLs for these SharePoint sites. Then I thought, okay, but what can I do to improve this? So, and at that moment I used OpenTelemetry annotations. That's just a very small library you can include in your application. Also, if you have, for example, just a simple Spring application, and you use auto instrumentation, if you just add the annotation jar, that is also picked up by the auto instrumentation library. It knows, hey, these annotations I know, and it's creating, in this case, it's creating a span, retrieve SharePoint sites, and this is of internal. So the internal actions you do in your application, you can make traces out of that as well, or spans. So let's have a look. So here we have a trace like that as well. So the original request coming in, and also the retrieve SharePoint sites. But still, it's almost about the same length. So all time is being spent there. So can we get more information about it? So there's also the OpenTelemetry API jar. So you have a number of APIs, and then you can say, okay, but in your code, for example, give me the current span. So the span which is active at the moment, that code is executed. Then you can do a number of things. You can add, for example, a number of attributes, which you can then see in the trace view as well. Or you can add events. And at the moment you add an event, it's also keeping track of the time you add that event. And that's shown as a relative time from the start of the span. So in this case, I have, for example, events for the name of the SharePoint site which was fetched, and also the size count, how much SharePoint sites was fetched. So if you add that, so I hope it's readable, but here you can see SharePoint sites count, 15, and you can see here all the events. And here you see already, time is adding up when fetching the SharePoint sites. So this already gives a bit more information. But I thought, but OK, HTTP client does have OpenTelemetry support. It also is documented, but the MS Graph SDK Java core library did not support it yet. So I created a pull request, solved it, and then I got this. And then you see all the requests are going. So the first request is, okay, give me the list of SharePoint sites I have access to. And then after that, for each of these SharePoint sites, what is the URL for this site? And then when I saw this, then I thought, this is not a good idea. But this helps to visualize. So if you have it visual, then you know. But I think I have to make some changes to this to get this better. And then you can think about all kind of things like making things parallel, or caching, or whatever. But at least having it visual helps you to understand what's going on. I used some caching, and then you can see the first time it still does all the calls to get the URLs, but these URLs are cached. So the second time you do the call, it's just give me the list of SharePoint sites I have access to, and then it's done. And with this, it's way more efficient. But if we go back to this one, I've seen also from production quite a number of traces where this was not just an external service, but also, for example, all the calls to the database, where Spring JPA was used, and it went 30, 40, 50 times to the database. So then you think, maybe we have to optimize a number of things in the way we use it. Connected services often also lead to connected problems. Because if you have one service having problems, that's most often also then having impact on the other services. And this is a demo from OpenTelemetry. OpenTelemetry community created a demo setup where they implemented a web shop where all the components were implemented with a different programming language. Don't try this at home. This is not the most efficient way. But it showcases what can you use and how can you use it, and it gives a lot of information, and also it gives an examples on what you can do and how you can instrument, for example, these things. And what you can see also here, for example, is also they implemented a Kafka queue and also services after the Kafka queue, but also you can see with that also the traces going through Kafka and then being picked up as well. And also database or all these type of things, but also a load balancer, etc. Unfortunately, I don't have time to show this in a demo, but what I can show is if you have all this data from all these traces, what you can do is based on the traces you can generate service graph metrics. So you know based on the trace which of the services are connecting to which other service, and with that. For example, Grafana Tempo is generating service graph metrics, but also the OpenTelemetry collector can do that. And with that, you can get metrics. How often is service A calling service B? And if there are problems as well, that's also registered. And then you can have a service graph like this. This is I created a Grafana plugin with a Sankey flow to visualize the flow between the services. But if you have a problem in your service, one of your downstream services, so here at the start you see here the user is sending a request to the proxy, to the front end, and to the checkout service, to the payment service. But if the payment service is having problems, that propagates to the in the end to the user. So this will help you to find where are the problems, not just with a single service, but also in a set of services, and how you can bring it all together and find the problems. And that is the power of standardization and also the naming conventions, that things are named equally in all all the programming languages as well. So, what is observability? That's where we started as well. So, how effectively can you get more information out of your services so that you know what's going on? We've seen a number of problems where you can get insights, and so based on this I was able to fix in the end the configuration problem, but it could also have memory allocation problems as well. But also where you can see where the context helped in the correlation as well to find a number of problems. So that was the second problem with the errors, where the information was available in the logging as well. Or where, for example, the traces, with the trace for at problem 3, where we were able to see the gap between where the request started in service beta and where the request was sent from beta to alpha. And also, adding more observability will help you to identify, for example, inefficiencies. And one of the really powerful things of OpenTelemetry is the correlation and also the standardization and the naming conventions. And if I can give you an advice, start gathering your observability data in a standardized way. And I would say use OpenTelemetry, as that is at this moment at least the industry standard for that. And now about you. How can you fix it or practice things? So a few months ago, I created the first application observability code challenge. And what I did there is I created a sample application with some problems, obviously. That application, also some test scripts you can run. That application is sending telemetry data to OpenTelemetry collector, and you can use also, and that's what I prepared as well, you can use the Grafana tooling as well to get it more visual. But in the end, what counts is you can make changes to the code, and you can see based on that what is the result of it. Make changes and check the result. That will help you to practice these things, and also what can you do to make the application more observable, and what can you learn from it. Because in the end, if you practice it more, then you also know how to recognize the number of things if you face them, for example, in production. And you can use your own observability stack if you want to. You can just use a collector and send it to your own observability backends. If you use in your daily work other type of tools, you can use that as well. And if you don't want to pollute your own system, there's also an online environment you can use. So I prepared also a number of steps where you can use Killer Coda. It's spinning up a JVM. You can use it for 1 hour, what I've seen. And then you're taking with a number of steps through it. You can go step by step, execute the scripts, see what's going on, make changes, and then run the scripts again. And then it's about, this is just a glimpse of it. With test scripts, you can see with a higher load, the services are having high response times. And that is due to some problems in the application. So it's up to you to find out. And if you are adding more observability and in the end are able to find the problem, then you can run the scripts again, and then you can see it's all fine. And that's also one of the things. So if you measure the things, you also know if the solution is also the right way, or even making it worse. But at least you have the data about it. So next time they are knocking on your door, be prepared. Do you know what's going on in your service? Because either they will hate you, or they will love you. So that was it. If there are any questions? I don't know if there are questions, we can check. So, here are the questions. Would you recommend Loki or Logstash? Yeah, I use them both. But most recently I used Loki the most. And especially also the current integrations also with in Grafana, where you can do what they call the drill down logs. That are a number of features where you can easily drill down through the logs and find a number of patterns as well. That's what I feel is very helpful, and especially also the correlation, where you can go from the log line, trace IDs, and then go to traces and back and forth. But that's also possible with Elastic if you configure it in the right way in Grafana. So both can be used there. How do the agent technology, how the agent is communicating with the so the agent, so the next question, the agent can do some buffering, and that's why you also configure some timeouts. But if the agent is if the agent cannot connect to the collector, then it in the end will drop the metrics until the moment it can reach the collector again. So in that moment, if the agent cannot connect to the collector, you might lose some data, but it will not keep all the metrics and traces, etc., forever in your application, because that can give other memory problems as well, and that's what you want to avoid. Can OpenTelemetry be running forever? Yeah. Or should it must be able? Yeah. So it's more the question: do you maybe do you want it to only run if you are problems, or continuously? I think that's the question. But yeah, I'm running these type of things continuously on production, because otherwise you miss out the things which actually happen on production, especially if there are problems. Then you miss them. So I would say, also have them on your dev and test environment, etc. Because then you also can compare the data you have from these environments and your production environment. And it also helps you to see, okay, but we see different things on production compared to acceptance. Then it might be because of load, but also that can help you. So we see a problem on production, can we somehow reproduce it on acceptance? And then you also know if you fix it, that if you have fixed it on acceptance, that also on production it's more likely that you fix it then as well. I think I covered that one. Do you have any measurements on the load overhead? I don't have measurements, but what I read about it, it's about 1 or sometimes 1 or 2% overhead. So I think that was it. Time's up. If you have any questions, you can reach out to me. Just talk to me. You can also plan a one-on-one meeting. I'm available today and tomorrow if you want to. Thank you for joining the session.